This is Note-Taking Guide 4.1 for Math 1. Today we're going to talk about what a sequence is, and then we're going to talk about a special kind of sequences called arithmetic sequences, and a special kind of sequences called geometric sequences. So what is a sequence? A sequence is a set of things, usually numbers, that are in order. So here we have a number 3, 5, 7, 9. We can tell what that order is going to be because we know a pattern that's going to happen between 3 and 5, between 5 and 7, between 7 and 9. So the sequence is formed and we can actually find the next numbers in that sequence if we wanted to. So when we're talking about a sequence, the first number is called the first term. The second number, second term. Third number's third term, and so on. These dots right here mean that it goes on forever following that same pattern. So there's two kind of sequences we're going to look at today. The first kind of a sequence is called an arithmetic sequence. This is when each term is determined by adding a constant value to the previous term. So this constant value is called the common difference. An example would be this sequence right here. We go from 3 to 6, 6 to 9, 9 to 12, 12 to 15. And how did we go from one value to the next value? Well, to get from 3 to 6, we added 3. To get from 6 to 9, we added 3. To get from 9 to 12, we added 3. And to get from 12 to 15, we again added 3. Because the addition of 3 happened throughout the entire sequence, this is an arithmetic sequence. We added a constant value to each previous term. This arithmetic sequence has a common difference. The common difference that it is the number that we added to our pattern. So in this case, a positive 3. All right, just like arithmetic is found by adding a number to the previous term, geometric is found by multiplying the previous term by a number, a constant number to get to the next number. That number that we multiply by is called the common ratio. So here's an example right here. How do I get from 5 to 15? I times by 3. How do I get from 15 to 45? I times by 3. How do I get from 45 to 250 or 225? I times by 3. So this is a geometric sequence and it has a common ratio. The common ratio is the number that we use to multiply by. So in this case, the common ratio is 3. All right, so what we're going to do is we're going to look at these sequences here and we're going to decide if they're arithmetic or geometric. So how do we get from 5 to 6? Did we add a number or did we multiply by a number? I'm going to guess we added a number because to get from 5 to 6 multiplying would be rather difficult with a fraction. So what do we add 5 to get to negative 6? I'm thinking that negative 11 might work. Do I add negative 11 to negative 6 to get to negative 17? I do. So I really subtracted 11, but it's really like add a negative 11. And then from 17 to negative 28, I again added a negative 11. This is going to be arithmetic because I added a number. The number that I added, the common ratio, happens to be a negative 11 this time though, because the number we added was negative. Arithmetic have common differences. I think I might have just said common ratio there, so if I did, I'm sorry. The common difference is negative 11. All right, let's look at this next one right here. How do we get from one number to the next number? How do we get from negative 4 to 12, 12 to 28, and then 28 to 42? I think that this is going to be addition again because multiplying in my head, I can't get that to work out right. But how do I get from negative 4 to 12? Let's try adding 16 and see if that works. Negative 4 plus 16 is 12. 12 plus 16 is 28. 28 plus 16 is 42. So this one is, again, arithmetic. And if I wanted to know the common difference, it would be a positive 16. All right, last one right here. Again, we're trying to see if we have arithmetic or geometric. So how do I get from the previous number to the next number? So looking at this right here, how do I get from negative 6 to 3? Well, I could divide by a negative 2, but that doesn't work the next time because then I would divide by a negative 2, and so it doesn't work right there. So let's try this with addition. How do I get from negative 6 to 3? I could add 9. Oh, there we go. We could add 9 again there, and we can add 9 again here. So these happen to all three be arithmetic, but they don't have to be. Sometimes they're going to be geometric. Okay, there is a story problem here. It says, fill out the table from the story problem. Is the sequence arithmetic or geometric? You ran a business making birdhouses. You spend $600 to start your business, and it costs you, let me see how much that says on my paper, $5 to make each birdhouse. So $5 to make each birdhouse. So let's figure it out. One birdhouse is going to cost you $5. The next birdhouse is going to cost you $5 more, so 10. Then 15, 20, 25, 30, and 35. So looking at this, how do I get from 5 to 10, from 10 to 15? What do I do get from one number to the other? I add 5 because I'm adding 5. This is arithmetic. And the common difference would be adding 5 or plus 5. All right, this next problem says consider the arithmetic sequence. So I know it's arithmetic this time, which means I'm going to be adding a number to get from one number to the other. It says find the next 3 terms and then graph the first 6 terms. So it tells me here that I'm going to be graphing the first 6 terms. So here's 18 to 14, 14 to 10. How do I get from 18 to 14? I add a negative 4. How do I get from 14 to 10? I add a negative 4. So this one's going to be 6 because I add a negative 4. This is going to be 2 because I added a negative 4. This is going to be negative 2 because I added a negative 4. And then this is going to be negative 6 because I added a negative 4. So then what I got to do is I need to graph this. So here's it says right here that my domain is 1, 2, 3, 4, 5, 6, 7. Let me tell you what it's talking about here. It says we're using a first term, a second term, a third term, a fourth term, a fifth term. So what we're really doing here is we're using some sets of ordered pairs. My first term was 18. My second term was 14. My third term was 10. My fourth term was 6. My fifth term was 2. My sixth term was negative 2. It says that we only need to graph the first 6 terms, so I'm done there, but I could have said my 7th term was negative 6, and I could have also graphed that. So let's graph these and see what happens here. So I'm over 1 and I'm up 18, so right here. I'm over 2 and up 14, so about there. Over 3 up 10. Over 4 up 6. Over 5 up 2. Over 6 down negative 2. Okay, so here's my graph. I'm actually not going to connect the lines on this because I only have terms. I have the first term, the second term. I can't actually connect these lines right here because that means that I would have like a 4.5th term. And I don't have terms in between the like 1 and 2. I only have exact terms here. So I can't connect the dots here. So I'm going to just leave these dots there as my answer and move on. All right, here's another arithmetic sequence. Here I have negative 4, negative 1, 2. It says find the next 4 terms and then graph the first 7 terms. Well, if I'm graphing the first 7 terms, my domain or the values that I'm looking for here are my first 7 terms of my sequence. So 1, 2, 3, 4, 5, 6, 7. My range is going to come from my sequence up there. So I have negative 4, negative 1, 2. So the question is, how did I get from one number to the other? How do I get from negative 4 to negative 1? I add 3. How do I get from negative 1 to 2? I add 3. So my next term would be added 3, so it would be 5, then 8, then 11, and then 13. So I've actually formed ordered pairs again. My first ordered pair is 1, -4. My second ordered pair is 2, -1. My third ordered pair is 3, 2. And I'm just going to graph these ordered pairs. So I'm over 1, down 4, which is actually it's off my graph down there somewhere. I'm over 2, I'm down -1, which is right here. I'm over 3 and I'm up 2. I'm over 4 and I'm up 5. I'm over 5 and I'm up 8. I'm over 6 and I'm up 11. And I'm over 7 and up 13. So again, not going to connect these dots together, but if you look at these, you can see that it's going in a straight line there. Don't connect the line though. Okay, this next one says consider the geometric sequence. My geometric sequence says 32, 8, 2. It says find the next 3 terms and then graph the first 6 terms. So if I'm graphing the first 6 terms, I'm 1, 2, 3, 4, 5, and 6 on my domain or my x values. My range is going to be 32, 8, 2. And how did I get there? How did I get from 32 to 8? I actually divided by 4, which is multiplying by 1/4. Sometimes it's easier to think about as divide by though. So how do I get from 8 to 2? I divided by 4. How do I get from 2 to the next number? I divide by 4. So I would get 1/2. I would divide by 4 again, or times by 1/4. And I would get 1/8. I would times by 4 again, or I'm sorry, divide by 4 again, or times by 1/4 again, and get 1/32. And I would keep going on that. So then let's just graph it. So my first ordered pair is 1, 32. So I'm over 1 and I'm up 32. Then I'm over 2 and up 8. That changed dramatically, didn't it? I'm kind of right here somewhere. I'm over 3 and up 2. I'm over 4 and up 1/2. I'm over 5 and up even less and less and less. So clearly not a line anymore on this one. So this geometric one was not a line. The 2 arithmetic ones I did though were lines. All right, let's take a look at the last one and see what happens. Consider the geometric sequence 2, 4, 8. Find the next 3 terms and graph the 6 terms. So my domain are going to be my numbers of terms 1, 2, 3, 4, 5, and 6. My range comes from my actual terms. How do I get from 2 to 4? I times by 2. How do I get from 4 to 8? I times by 2. So I'm going to continue to times by 2. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. Then I'm going to graph these ordered pair. My first ordered pair is over 1, up 1. Oh, actually over 1, up 2, but I'm probably okay in the right order, still kind of right there. I'm over 2, up 4. I'm over 3, up 8. I'm over 4, up 16. I'm over 5, up 32. I'm over 6, up 64. And then if you just look at that, that's a curve again, not a straight line. So the last question says, well, what do you notice about the graphs of arithmetic and the graphs of geometric? Well, arithmetic will always be linear. And geometric will always be exponential or a curve, which is what an exponential graph looks like. So keep that in mind when you're graphing. If you end up graphing it and it's a straight line, then it's going to be arithmetic. If you graph it and it's a curve, it's an exponential function, which is going to be geometric. Thanks for watching, you guys. Good luck with your homework.